inspect every small detail with the absolute concentration of people who understand that safety never exists naturally.
Action prevails. Every morning inside that clean, quiet, disciplined environment always begins with procedures ripped so consistently that arguments. But within that seemingly stable environment, the greatest question of modern aviation still exists like an invisible pressure. Why can a small change inside a seemingly unimportant system affect the entire safety level of a flight traveling thousands of kilometers through the sky?
The engineer checks the temperature indicators and understands that no data is allowed to be ignored, even if it deviates only slightly from the normal limit. The workers aged 22 to 25 move around the matte gray metallic fuselage in near total silence, because every action here is directly connected.
For the people working inside the maintenance hangar, it resembles a living body, continuously dependent on the coordination of every component. Aviation has never believed in the concept of absolute safety, but only in the ability to continuously control every existing risk. From that point forward, systems thinking became the core foundation of aviation, because no one remained naive enough to believe in. In normal operating conditions, every system inside the narrow-body aircraft with matte gray metallic surface continuously
A temperature sensor that appears related only to the electronic compartment can actually indirectly affect the operational stability of many other systems throughout the flight.
The workers upload. The workers aged 22 to 25 replace every small component, according to strict procedures. Even an improperly tightened force setting on a very small component can create abnormal vibrations spreading through many other areas of the aircraft fuselage while flying at high speed.
The clean, quiet, disciplined environment behind the terminal exists because aviation understands and that serious failures rarely appear. The male engineer aged 25 to 30 continuously compares data between systems, because an abnormal number is sometimes not the fault. Systems thinking in aviation therefore means not only understanding how each component functions, but also understanding how they influence one another across thousands of different situations. And from this point onward, aviation safety began to be defined not by the strength of each individual component, but the greatest contradiction in aviation lies in the fact that the more systems coordinate with one another, the greater the risk of creating complex interactions beyond prediction.
We have anomalous spikes on the main conduit. I need inspection teams in grid sectors.
Grid sectors HISTed immediately. The workers aged 22 to 25 begin scanning the entire technical area, because experience in aviation shows that small deviations almost never appear randomly.
What makes aviation different from many other fields is that it does not wait for accidents to occur before investigating, but instead tries to understand every abnormality.
Abnormal data is sometimes only the final result of a chain of effects stretching across multiple layers of systems.
A sensor failure can cause the control system to receive incorrect data. Incorrect data can inaccurate reactions, and
Conventional linear thinking often tries to find one direct cause for every failure, but aviation understands that accidents usually emerge from many small causes.
This historical data sequence shows a spike right here.
Okay, let me inspect that connection closely.
The atmosphere inside the maintenance hangar behind the terminal becomes more tense, because everyone understands that the most dangerous thing is not a large visible failure. That is also the moment when systems thinking proves its true value, because if people only observe each individual component.
The core reason aviation safety depends on everything is that a modern aircraft does not operate like a disconnected collection of devices. When the electrical system changes its operational load, the temperature of many other areas also changes, and that can affect the stability of sensor data.
The male engineer aged 25 to 30 continues analyzing and realizes that a small temperature change can also alter the material. The workers aged 22 to 25 recheck the entire data transmission network, because a system like an aircraft. Incorrect information.
Aviation understands that a system is truly safe not only when it functions correctly but when it also reacts correctly to every surrounding change occurring around it.
That is why systems thinking becomes a mandatory foundation, because no one can evaluate the safety level of a device.
The female engineer aged 22 to 25 compares data from multiple systems to confirm that every Rerouting the power matrix now.
If even one connection reacts a few seconds slower than normal, the entire automatic decision chain inside the flight systems can shift in a direction no one wants.
That is why aviation builds countless layers of cross-checking, because it understands that failures rarely appear alone. The original voltage fluctuation was actually only the surface sign of a reaction chain connected to system loads and temperature conditions inside the technical compartment. From that point, the entire engineering team understands more clearly that aviation safety does not depend on one perfect component.
If viewed conventionally, many people would believe the engine alone determines aircraft safety because it directly generates the thrust for flight.
But systems thinking in aviation shows that even a powerful engine cannot guarantee safety if sensor data, electrical systems, and
Plutus. The female engineer, aged 22 to 25, continues checking data reactions and realizes that the greatest value in aviation.
The workers aged 22 to 25 operate in nearly perfect synchronization because even procedures are considered an inseparable.
Beeble indentations. A modern aircraft may contain extremely advanced technology, but if communication procedures between humans fail.
The African-American male engineer aged 25 to 30 remembers that many aviation accidents throughout history did not originate.
Systems thinking therefore differs completely from the simple belief that fixing the broken component alone will make every problem disappear. In aviation, every change anywhere must be evaluated based on how it will affect the entire remaining operational network of the aircraft.
The narrow-body aircraft with matte gray metallic surface rests silently inside the maintenance hangar behind the terminal.
The South Asian female engineer, aged 22 to 25, looks along the aircraft fuselage, the white lights, and understands that there is no.
In the end, aviation realizes that safety is never created through absolute perfection, but through the ability of systems to continuously monitor and support one another. All indicators stabilize, confirming that the most reliable thing in aviation is not isolated strength, but total coordination. The narrow-body aircraft with matte gray metallic surface beneath the cold-directed lights now resembles the clearest, because in the sky, no component truly exists alone, and no failure is ever completely separated from the rest of the operating system surrounding it. Systems thinking in aviation ultimately becomes not only a way of designing aircraft, but also a way for humans to view every problem as interconnected relationships. And perhaps that is the true reason why the safety of a flight always depends on everything, rather than depending on any single thing alone.